Hello everyone, welcome back to another video where we're going to be doing more Leetcode, and today we're going to be doing encode and decode strings, which is a pretty interesting problem, clever problem. So let's get right into it. So design an algorithm to encode a list of strings into a single string. The encoded string is then decoded back to the original list of strings. Please implement encode and decode. So we have two functions here instead of one. That's fine. So here we have the input, which is just a list of strings, and then the output is the same exact thing. So it doesn't really help us there, but it's pretty simple. We have to encode the input, and then that encoded input we have to decode back into the original input we had. So the goal is simple. We have to get a list of strings, and our job is to turn it into one single string. Then the decode function needs to reverse that process and give us the original list back. So when I first saw this problem, and I bet this happened to a lot of people, they're like, oh, this is easy. This is really easy. The first idea people usually try is to use a separator. So like a delimiter. So why don't we just join the input here with a delimiter? So something like, so now neat, and then we'll use a pound for our delimiter. Neat code love you. And then now this is our encoded string. And then you just split on for the decode function, you just split on the pound and get back the original output and return that. Well, the problem is the input strings can contain any characters. As if you look down here, it can contain any UTF-8. I don't know why it's only UTF-8. It contains any UTF-8 character. That's a lot. So what if our pound here, our pound delimiter, is in the string already? So let's say code was like CO, like that. Then when you go to decode, this would become CODE. You would this would you create two words that didn't even exist in the original. So instead of relying on a symbol, the better approach is to store the length of each string before the string itself, so we can store the length. So why, instead of just using a pound as a delimiter, why don't we just store the length of the string and a delimiter character? So let's say for neat here, what's the length of neat? It is 4. So let's have it start with 4 and then a character delimiter, the pound, and then the word itself. And then same thing with code, we would have code and then love and then U, just 3 characters U. This would be our encoded string now. And here is why this would work. So the number before our special character delimiter tells us exactly how many characters to read next. 4 characters. If the actual string has a pound in it, if you're asking what if our actual string has a pound in it, like the previous example I showed, or digits or anything else, it doesn't matter because we already know the length we have to, like the amount of characters we have to go to get the actual full word from here. So decoding becomes deterministic. So read digits, hit the pound. So we would read the digits, then you would hit the pound. Convert to an integer, and then read that many characters forward, as I said here. And then you just repeat that until you get the whole original output again. So now with that in mind, let's jump into the actual code and walk through it line by line. So let's go here. So now we have the encode function. So this will take a list of strings and will return our one encoded string. So we have to encode the string. So let's have result, so it will return an empty string. So we're returning a string here. And then we have to loop through each word in the array, each string. So for s in strings, and now remember we have to have the length and the special character to separate from there before each word. So now how do we do that? So just concatenate to result, which is empty for now, but then we would do the length of s plus the pound delimiter, and then plus the word now. So then this will have the length. Obviously you have to convert it to a string because you can't concatenate, because the length returns an integer. You can't concatenate an integer and a string, so you have to convert it into a string, then concatenate. So then this will give us the length, the pound, then the string. This will properly encode our list of strings. So then we can return the encoded string. And that is it for the encoded function. It's pretty simple. But now we have to go to the decode function. So this function will get our single encoded string that we just encoded, and we need to reconstruct it to the original list again. So now we'll store the decoded words in the list called result empty array or list, and then we'll have a pointer I, which marks where we're currently reading in the encoded string at 0 for now. And then now we'll make a while loop. So we'll keep going until we reach the end of the encoded string. So each iteration of this loop decodes exactly one original word. So that's what we're doing in this while loop. So while I is less than the length of our encoded string s. And now here I'll create another pointer j. Sorry, that's the wrong way. And well, the reason I created another pointer j, starting at the same spot, its job is to find the pound that marks the end of the length. So that's the job of j. So now, when this loop moves forward, we'll have j move forward until it hits the pound. So let's say if j does not equal, let's say it does not hit, this will get rid of that for us. If it doesn't hit the pound, string at j, sorry. If it does not hit, then we can just increment j plus 1 and keep going until it hits this. If it does, then we have to store our length in a variable, the length of this amount of characters we have to go until we get our full word, and then add that to the result. So our length would be, obviously we have to store it in int first because it's a string. We'll return a string. So s at I, starting at I, ending at j. And why we're doing this is because j right now would be our pound. So if we're going from I to j, not including j, which is at our pound delimiter, then it will return us the length. The exact amount of characters you have to go to get one single word. So now we have our length here. Now we have to append the result. And now here we'll just simply S. So now the line, this line here will slice out the actual word. So the line, the word, remember the word starts right after the pound, which is j plus 1. So we'll start at j plus 1. And then it ends after length characters, which is a variable here. It'll end after length characters. So we'll do this j plus 1 plus length. And now this is basically done here. But now we have one more thing to do. What do we do with I? You must be thinking. So now we have to update I so that now it points to the start of the next encoded chunk. So we'll just have to set I equal to j plus 1 plus length. So now this will set I to the next encoded chunk. It'll set I to the start of the next encoded chunk, and then it can do the same thing again. Now this will fully decode our original. This will successfully decode our encoded string back to the original state it was in. So now we can just return result, and we can run this now, and it should work. Yep, there you go.